This is Ben Buckley reporting from the show floor of Interbev in Vegas 2012. I'm at the Radical Waters stand. I'm delighted to be joined by Carla Fyford, who's MD of Radical Waters. Hi there, Carla.
Hi, Ben. Nice to meet you.
Yeah, you too. Now, electrochemical activation, Carla. I mean, it sounds like a progressive rock band, but it's actually a breakthrough cleaning technology that's highly relevant to the beverage industry. I mean, perhaps you could explain to us what is ECA and how can it help bottlers?
It is more progressive than a progressive rock band, in fact. Electrochemical activation of water is a process whereby you use water, salt, and electricity. You use a positive electrical impulse and a negative electrical impulse, and you produce an on-site detergent and sanitizer for a beverage factory to use in their CIP process. The exciting part about this is that it's green. It replaces all chemicals in the plant and significantly reduces water and heat usage, and it reduces the time it takes to do a CIP between runs of different beverages.
Okay. As I understand things as well, you can also cope with pungent flavour changeovers.
Absolutely. Far more effectively than a normal chemical traditional CIP, where you would have to use high temperatures of very toxic chemicals. We can run at ambient, at room temperature. We can run a 15-minute or 30-minute CIP, and we can completely eliminate flavour carryover. We can eliminate aroma, and we can eliminate colour more effectively than a traditional chemical CIP, which is really exciting.
Yeah, it sounds it, Carla. Okay, I just consult my script here. And how does microbiological performance compare with traditional bought-in detergents and sanitizers?
Ben, it actually compares very favourably in that the micro that one finds in a beverage plant or in a food processing plant have actually built up a chemical resistance over the year, just as humans have built up an antibiotic resistance. It's exactly the same process, and the difference with this is that there's no chemical resistance, and your bacteria, your molds, your fungi, and most particularly your biofilm are actually eliminated, and you actually get a zero microcount. So biofilm that might have been hiding in the plant, in crevices in the pipes for many, many years, unbeknown to the plant sanitation manager, actually comes loose and is actually eliminated and killed off, and you have a very good log reduction. So our microbiological performance is actually outstanding.
Okay. And I mean, what would you say to the skeptics amongst our viewers who might say, it all sounds too good to be true? There's a cost implication. I mean, what's the typical payback time?
There is a cost implication because as opposed to paying for chemicals on a monthly basis, in this instance you have to purchase a unit which you would put in on site in your plant, which would produce the detergent and the disinfectant. In terms of the requirement for CapEx, we have come up over the years and we've learnt our lessons. We can now, the buyer, the beverage plant or the food plant could actually lease a unit or pay on a cents per litre. A typical payback on a beverage plant, particularly a very busy beverage plant, and obviously the busier the plant, the more shifts they're running, the more changeovers of product, the lower the period of payback, but our average payback is less than 2 years, which makes it really very effective, especially when you're showing a water saving of 64%, and in terms of sustainability and the great pressure on all the beverage manufacturers, be it a brewery or a carbonated soft drink, to reduce their water ratio. Your payback is sustainability plus a financial payback of less than 2 years.
Okay, thank you. And I mean, as I understand things, Carla, I mean, the patents for ECA technology appeared around 10 years ago, but it seems that, how fair is it to say that it's only really taking off now in terms of uptake?
Ben, that's correct, but just to also avoid some confusion, there are two kinds of patents in ECA technology. There are some patents that are due to expire in the next 2 years on the actual reactors. The reactors were originally invented in Russia, and those patents have been largely fought over. Radical Waters has chosen to choose the applications to patent. So how do you use the solution in a plant? And we've just recently been granted in the US the beverage patent in terms of, and then of course it's a patent, not a patent, because it's US, and that reduces, that shows the savings in water and a changeover from a 5-step to a 4-step CIP. So the growth has really been in the last 3 or 4 years. The recognition of the largest beverage companies has been in that period. And geographically, where am I seeing the most potential? Probably right now in Asia. And that's where we're seeing an enormous amount of attention. They're under a lot of pressure from water and an enormous amount of growth in terms of people drinking carbonated soft drinks, waters, energy drinks, and a lot of their plants are running 365. So if we can save them water and time, that's where you're going to see the growth.
Yeah, sure. And I mean, just finally, in terms of your customers, is it just the big boys who are interested in ECA or SMEs as well?
No, funny enough, we have some SMEs as well. The big boys are certainly very interested because they're under the most pressure, but we have some SMEs as well, particularly in countries where as water pressure, water sustainability are very key, and a lot of interest now from the craft breweries and the microbreweries, which is a great area. They all want to be green and they want to be sustainable.
Well, thank you for those insights, Carla. It sounds like if it isn't a progressive rock band, it is at least progressive. This is Ben Buckley reporting.